We'll do it live. It's going to be a fun show.
I hear
Cool.
foods.
Mike, I feel like I detect a tiny little bit of accent in your voice, or am I just crazy?
Yeah. So I got that before
Depends on
too.
where you
I'm
are,
from
I
New
suppose.
Mexico, but somebody thought I was Australian the other day.
I was going to say, you
So-
kind of sound Australian, and I'm very confused. As an Australian...
No, born and raised in New Mexico, but maybe I'm just exotic.
Yeah, it's
don't
weird.
know.
I think it's when you say, like, the letter O. Like, oh, no. When you said the word stuff, I was like, you said that like an Australian. What's going on? And, like, some of your words sound Australian. It's completely... It's messing with my head, because I'm Australian, but, like, I lose my accent when I move to other countries. So I'm like, am I hearing it, or am I just wishful thinking? Like, I don't know.
In case you were wondering, you still have a little bit of
maybe it's
your
one of those
accent.
I was
things
gonna say, you sound plenty Australian.
Do I?
Compared to us.
I mean,
yeah.
okay, yeah.
Very honest, yeah.
Ben,
Well,
three
maybe not
needs
compared to me,
focus.
but
Ben, 3 needs focus. Benjamin?
9 minutes out.
3 needs focus.
right.
Camera 3 needs focus.
I did my best to organize my thoughts on this story, and we're just gonna see how.
Yeah, I mean,
I
I'm just
wrote
gonna...
way more than I meant to, but I already know what I'm gonna say.
I'm just gonna throw questions at you, so...
throw them
That's
right
almost-
in my face.
Yeah.
Yeah,
And I'll catch them with my teeth.
cool.
Jared, that's a good look for you. Keep that.
What, blurry?
Oh no.
I know, with his face covered, that's not really nice.
Jared's beautiful. Look at that. Oh, he doesn't have his ears in. Can't hear him.
Oh, he can't hear us.
I thought I really hurt
Oh.
his feelings. I was like, he didn't reply to me. Usually he has a clever quip coming right back at you.
I need to get
All
myself
right.
a mohawk so I extend my height by a few inches.
Only serious since I'm making everyone else do it right in front of your face for me, right at 4.
That's so creepy, Ben.
What are you talking about? Ben's always creepy.
Yep.
All right. How much battery does my laptop have? Cool, we'll make it through.
Behind the scenes stuff that nobody ever sees. Is my laptop gonna die?
These are the things we worry about, you know, on the show. It's like, does everyone have enough battery power? Did everyone get new batteries? I probably should have checked.
I got a new battery,
Yeah.
so...
Okay, cool.
Transmitters and receivers, yes?
I believe so.
9 volts and the battery packs for cool, yes. Jared, how about you?
Is there a way to see what the battery level is on here?
Oh, if you didn't put a
Point
new
the
one in there,
screen.
then you're going to need a new one.
Oh, okay, I'll be right back.
Oh, they're right here.
Oh, I'll be right back.
We need more batteries, Ben. I think more 9 volts.
In the cabinet down below.
Oh, okay. Ah, it won't open.
Here.
Oh yeah, there's heaps. Don't worry. Cool.
For
One's
next time.
rubbish.
Jade versus.
There's a...
Open.
That was 2. Yeah, that, no, you have to say it louder.
Open.
Open.
Open sesame.
Please.
So,
Computer?
sorry.
It's okay.
So this comes like that. You just push it forward.
Yeah.
That was actually filmed.
Lift.
That scene was filmed.
Oh, really?
This is engineering at its finest.
Finest, I'm not sure that's quite right.
I don't think it is.
Whoa, elitist over here. Okay. Sorry, my
Now,
plebeian mind.
If you feel on the side, there's a little lip.
Yeah, there's a lip.
So
Push.
push up. and kind of turn,
Neuropilot.
rotate.
The glitter that I use
Took me,
is
Try.
took
from
me forever
I
to
bought
get
it from
it.
Sephora,
That's right.
and it's
Thank
the
you.
brand Too Faced, and
Thank
it's
you.
like a unicorn
Is that in
eyeshadow
the
palette, and
right
that's what I
way?
use for my sparkle glitter on the
That
show.
thing in. Thank you.
Just if you're wondering, Neuropilot.
Me? I'm definitely wondering. Thank you.
My thing down, flip it, and reverse it.
Does everyone know that she calls this her unicorn war paint?
See that stuff?
that's
That
metal.
It's my sparkles.
That is
Helps me.
It
excellent.
literally makes it nearly impossible for me to actually get a good skin tone calibration on the camera because it actually reflects the entire rainbow of light back at the camera. And so I just have to like give up and do skin tone on anyone other than Lisa.
And what is this this wonderful palette called?
Oh, it's like a unicorn eyeshadow palette. I don't know if it has an actual name.
I feel like
I thought that one was Unicorn Tears.
Oh, yeah, so this particular color is called Unicorn Tears. Yeah.
Hilarious.
You're welcome, Chris Radcliffe. You're welcome.
she's powered by unicorn.
I am.
For anyone who ever
Unicorn.
wondered.
So true. It's so true.
Nice.
5 minutes.
5 minutes.
5 minutes out. 5
You
minutes
guys
out.
ready for tomorrow?
Because it starts right now.
In 5 minutes.
Tomorrow begins right in 5 minutes.
Yeah.
So I'm going to give everyone a reminder for the cold open. I'm looking for the engaging moment that's going to draw people into the show. So I want something that people are excited about. Not looking for a one-sentence descriptor. I'm looking for. Sorry, I've actually forgotten what your news stories are. You're doing
Chinese
the
launch
Chinese
startups.
launches, like something along the lines of. Commercial spaces moving into China, and they've got a bunch of I don't care, just something that like draws people in.
Did you just say you don't?
China is
I do
going to
care.
dramatically reduce the cost of getting to space.
Through competition.
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 What?
Co-opetition.
Oh, and then Mike and I, after the show, are going to have a battle to the death over Gateway.
Battle to the death over the lunar orbiting platform Gateway.
Can I join in on that battle to the death?
Can I step in and just...
Jade, your
can be
news
only-
story
Yes,
is
you
the
can,
asteroid
Jared.
miner,
Absolutely.
Excellent.
Yeah.
Sounds good to me.
Play devil's
USGS
advocate
finally
for
getting
both
serious.
sides and just confuse us.
Oh, I sure will. I'll play
Yes.
devil all
How does
day.
that
So,
change
Here's
the world?
hail Stan.
In a lot of ways. Oh, you're talking about what I'm going to actually say? Oh, yeah. I was
Gibbers-
like,
gibbers
just asking
crabs.
right
Yeah,
now.
just
Yeah,
questions
which of your news stories do you want to talk about in the open?
The USGS is finally getting serious about mining extraterrestrial resources.
Who's
Dang.
USGS? Is that
Oh, I'm sorry,
a
the
division
U.S.
of the post office?
Geological Survey.
Oh, okay,
for
cool.
You
So
common
that's,
folk.
That's more of
Thank
a
you.
headline and less of a. So I really want
Yeah,
to pull out
exactly.
the like why the hell we care. So,
Yeah. And this can
If
mean...
you've ever wanted to
and-
mine extraterrestrial asteroids, boy, have we got a new segment for you.
Yeah.
I think
Yeah.
it's way more catchy than Uskus. Uskus. Something that like really pulls in like why the hell the viewer should care.
Oh, yeah.
Yeah.
Okay.
By the way, I want to say
Same thing
hi,
with you.
Mike. I'm interviewing you today. I'm Jared. So good to see
Hey,
you.
Jared.
Super,
Up there.
Same thing,
super
like,
excited
Good
to
to meet
talk.
you.
The why,
So
right?
it's gonna
Why
be-
do you
it's gonna
care
be
that China's
awesome today.
building commercial space? Why does it matter? I need
Yeah,
a one
good to meet
sentence
you.
why it matters.
Yeah,
and why it's
I've-
going to change the world.
There was
Okay.
a
Everything
lot
we're
of stuff to
talking
go
about is
over.
changing the
So
course of
this is going to be
humanity. So we need
this is going to be
just
really
one
cool
sentence to be
today.
like, this is why this is
Fantastic.
absolutely critical and important. That's all. Great, thank you.
This is important because Ben
Thank
said
you.
it is.
Well, so
yeah.
I will say the cold open is one of the most important parts of the show because this is what will determine whether people decide to stay or go.
Yeah.
So I need to hook them in, and once we've got
2
them
minutes.
here, do you want ants? This is how we get ants.
I believe you're the reason we got ants last time.
I believe that's true.
No.
All right, that's all. Enough
Caffeinated.
2 minutes.
Very monotone. Ben, you left your box. Nothing. Nothing.
Walking
She was saying you left
into
your
the,
box,
room.
but-
Once again, battle royale.
Is everyone's phones on silent?
I'm going to be in the
Whoops,
corner and wait
yep.
until the ladies figure it
I'm
out.
going to turn my music
Phone on
off.
silent? Phone on silent?
I believe so, but never hurts
Remember
to
that time
double
the phone
check.
went off during the show? That was awkward.
What the deuce?
Phone to the side of the room. Okay, maybe not all the way.
Throw it.
I tried, but this isn't ice, so it didn't make it.
Speaking of sounds, my laptop sound is still on. Let's go and turn that off.
Hello?
Might help. Just a bit.
Hi, Julie.
1 minute.
Hi, Dwight. Yeah, everyone in airplane mode? Or rather,
I'm not
space
in
mode?
I'm not in airplane
Number
mode.
5 will shock you. Fake news.
That's a good question. Will the iPhone of the future have a rocket ship mode, not just an airplane mode. Think about it.
The iPhone of the future won't even have a phone mode.
Shut that door.
No text messages either.
And what's the point?
We'll just think the message.
All right, my clock says 11. We ready to go? Hello, welcome to tomorrow. We've had a most dramatic week in space. Jade, what's going on?
So, the U.S. Geological Survey is finally getting serious about mining space resources, and we could very well be on the brink of the 21st century gold rush.
Oh, how exciting.
Platinum and water and all sorts of goodies out there.
Oh, I love sparkly minerals in space.
Oh man, more money, government getting serious about it. That's going to actually happen. Holy
Right?
cow.
Yeah, and what else is happening, Mike?
Oh man, so as some of you may know, there are a lot of startups coming out of China, specifically launch startups, and there's 5 in particular I want to talk about because if these companies are successful through competition and cooperation, they're going to bring the launch costs way down and start making space way more accessible for everyone.
Oh, I'm excited for that too. And Jared has an interview with someone that you've all been wanting to talk to.
Yes, I have got the CTO of NanoRacks, Mike Lewis, here. We are going to be talking about making space accessible for everyone and actual hardware that's on the International Space Station right now.
All right, and then we're going to have questions and comments from you, the community. Stay tuned. This is tomorrow's Space Orbit 11.35.
Good morning. How's everything up in the sky?
All right, now we always like to begin our shows by talking about the coolest thing happening in space, which is launches. And there wasn't actually supposed to be any launches this week, but surprise! We had a launch. So, Mike, would you like to take us away for our launch minute?
Absolutely, absolutely. So, of course, it was a surprise Chinese launch, and this occurred yesterday on Friday, September 7th, 2018. And this was a Long March 2C rocket. It's the type that doesn't have any radial boosters included with it. And this launched from the Taiyuan Satellite Launch Center. And with this rocket, it actually launched at 3:15 Coordinated Universal Time and was launching the Haiyang 1C, which is going to be used to monitor the oceans in multiple ways. It's going to use optical imagers to measure the color and temperature of coastal regions in China and to measure aerosols in the water, and it was placed into a sun-synchronous low Earth orbit. But probably the coolest thing about this launch is that they actually were able to recover one, or at least some of the pieces of the fairing on this. And this is footage of from the fairing as it's coming down on a paraglide, and they were actually able to recover that. But we'll talk about that later. But China's done it again, and with less than 24 hours notice outside of China, they were able to conduct this surprise orbital launch. Everyone needs to step up their game if we want to keep up.
Oh my goodness, you nailed it right on that zero timer. Oh man. But Mike, you mentioned about the fairing. Is this the first time that China's done anything special with their fairing?
As far as I know, although this was successful, so that tells me that they've probably tried before, although I don't know. With this, they were able to recover the fairing nearby the launch site, and it actually fell into someone's garden.
What?
Yeah, we have some pictures, although I don't know who to credit for this. It was probably a local in the area who took these photos, but I apologize. We were not sure who to exactly credit for these images, but we found them on Twitter, and we had to share them with you guys. That's just amazing that they were able to recover it. And you can see from that side angle there that that's just the piece of it. That's probably just a top of one of the sides of the fairing. But in any case, they were able to successfully recover that. So I think that they've probably tried this before, and this just might be the first time that they were successful at it, or this was their first test and it was successful. But it helps that they were launching over land and had these areas that it could come over. But Oh man, this is just really exciting. And something about this too is that this is the 24th orbital launch for China with this Long March 2C rocket. And so they are powering right ahead. The United States is still only at 22 launches for the year and all the rest of the launches that have happened. But there's going to be quite a few more this month and in the month of October. I mean, the rest of the year, there's so many launches that are on the books that it could be very close. And there's quite a few Russian launches on the books too, so they might be able to catch up as well. So I'm very excited for things in the future. But
If you were a betting person, Mike, who do you think would top the launch count for 2018?
I hate to bet against my own country, but I think it's going to be China.
Especially if they
I
keep
want it
doing
to be the
24-hour
United
launches.
States, but it's probably going to be China. That's what I'm putting my money on.
$1 bet.
$1 bet?
I say U.S.
Okay.
$1 bet.
Ben bets
Just $1?
$1 bet for
That's the
China.
a maximum
$1 bet for
Tomorrow
U.S.
is $1.
Who is your horse?
Oh, U.S. I'm saying U.S. and you saying China. December and we.
All right.
New Zealand?
Show official time is UTC, so 23:59:59, December 31st UTC.
You know what you're going to be doing on New Year's Eve now.
Yeah.
Yeah, those are real plans.
And this is orbital only. Sounding rockets and suborbital don't count.
Right,
Orbital
just
only.
orbital
All right.
launches. Just orbital launches.
You saw it here first. The launch bet of tomorrow is now official. So thanks so much, Mike. That was an awesome
Yeah.
launch wrap up. Speaking of the United States,
Oh.
Jade, I
Yeah.
read your next
This is
news
cool.
story, and I was a little bit. This is something that has been talked about for a
Yes.
really long time from lots of different people.
Yes.
And it's space mining, right?
Exactly.
But this time, someone a little bit different wants to get involved. Who is it?
Exactly. So like you had mentioned, yes, there's already been a lot of talk and actually some plans to be able to mine resources in space because we are a very capitalist country. So if there's potential to make profit, then you better believe there are some mines already planning to go out there. But now we actually have some government entities that are interested, and the U.S. Geological Survey actually recently participated in a space resources roundtable at the Colorado School of Mines in Golden, Colorado. And they actually paired up with the Center for Space Resources to discuss some prospects into actually going out there and mining precious resources from not only asteroids, but potentially the moon as well.
Huh.
Yeah.
But I mean, okay, I get Geological Survey is looking at geology on Earth.
Yes.
But can that knowledge be transferred over to space?
1,000,000% yes and no. So the U.S. Geological Survey is responsible for surveying some of the resources we have here on this planet, so it only makes sense that as we go into the future, they also start to look at different resources in off the planet, extraterrestrial. And the things that we can find on asteroids are essentially the same things we can find here on Earth, but in large quantities and much more easily accessible.
Huh. Okay, well, let's go back to this this workshop that the USGS actually did.
Yeah.
Was there any kind of knowledge that came out of that?
Yeah, essentially it was kind of agreed upon. The general consensus is that while there's no actual funded program yet or directive from Congress, they foresee it as being something that is going to be sooner than later, and they want to be ready and they want to be prepared. And if that means that they may have to partner with companies that are already starting to pursue those types of things, then absolutely go for that. Yeah.
What about the challenges then of, mining in space is not really the same as mining on the Earth?
Exactly, and I'm glad you brought that up. So, as you can imagine, asteroids like this one right here, they travel notoriously fast. And not only that, but it's kind of tricky to determine which asteroid is actually going to be worth going up there and mining. We actually have a few targets. There's about 10 out of many that have already kind of been studied from here on Earth that could, A, be large enough, B, be close enough, and C, have materials that we could extract relatively easily that would make it worth even going up there in the first place.
Okay.
And go ahead.
Is that Vesta, this asteroid that we're seeing on screen, or is that a near-Earth asteroid?
I grabbed this image.
Jared's saying Vesta, so okay.
All right,
Jared would
thanks.
know.
This is why we have Jared on the show. We have questions that we can't answer.
Sorry, I was just wondering.
No,
This is really interesting, though, because for a long time, NASA has had a directive ever since the Obama years, back in 2010.
Yes.
We had this directive to send humans to an asteroid, and that kind of got canceled, and it became the Asteroid Redirect mission, figuring out how we can move asteroids with robotic spacecraft.
Yes.
And even though that all got canceled, too, there's
Unfortunately.
quite a lot of work on how we could potentially go and capture and rendezvous with these.
And I'm so glad you brought that up because it's interesting when it comes to a lot of space missions, you really do have to focus on the return on investment. And even Goldman Sachs put out a report about how profitable space mining can actually be. And they're not even like a science or a tech or engineering firm. Goldman Sachs themselves said, this could be the frontier of the next gold rush. This could be one of the most disruptive things to happen to any economy. And the fact that that mission actually got canceled is pretty ironic, considering you could potentially make an exponential amount off of what you invest into it. But you do need a proven sustainable model first before you go out there, because as of now, there's no real prospecting company that would have the initial funding to be able to, because it's pretty expensive, as you know, launching off of Earth. But there are, as you were talking about, launches are getting cheaper. And there's prospects of these things called nanosats and different kind of robotic prospectors that can go out and actually study some of these objects before we send out the big guns.
And that's exactly the goal of planetary resources, is to first start sending off, these small satellites to prospect these asteroids to see which ones contained rare earth metals and the type of things that we're actually trying to
Speaking of
prospect.
that, there's a question in the chat room from Hanny's Warweb on Twitch who asked about, the composition and how you make profit. Is there a certain composition that is best for asteroid mining?
Depends on who you ask. Depends on who you ask. There's some
Yes.
people that'll say, no, we really, really want to get the water. We want to get comets. We want to get ones that have tons of water on them so that we can, through electrolysis, convert that into rocket fuel and have an economy that way.
Exactly.
And then you have other folks who are just like, no, we got to go to the platinum-rich ones,
All
the
of them.
carbon-rich ones.
Well,
all of them could be useful.
The answer is all of them. S-types, M-types, and I forgot the other types of asteroids off the top of my head, but there's a letter associated with them.
Silicates,
Yeah,
I think.
so silicate-based or like carbonaceous asteroids, yes, you would have a lot of organic materials, so you would have a lot of prospects for mining water, which is just as valuable, because shipping all of that fuel for a return mission would be insanely expensive. But if you can, as you said, through that process, make rocket fuel out of the water already there, you're already saving a butt ton of money. And also, as you said, there are a lot of rare earth metals, there's a lot of platinum and a lot of gold, but you do need to be careful, because if you mine all of the copious amounts, you could potentially crash the gold and platinum market, and pretty soon everything we're wearing would be made of that stuff, because it would just be easily accessed.
Right.
However, the rare earth metals that make up our electronics, now that is something that could definitely be exploited, and that's definitely something that could disrupt the market in terms of we wouldn't have to rely on China as much to get their rare earth metals. They really harnessed.
They dominate
the
like
selling of those.
75% of the market.
Yeah, it's something insane like that. So in terms of just commercial value, the possibilities are just flabbergasting.
The biggest problem, though, is the money that it would take to get there in the first place. I know we need to move on, but that's kind of been the biggest problem up till now. So hopefully something like this is going to, give kind of that official stamp on it, and through cooperation be able to find those resources that would,
Exactly.
have investors invest that money to be able to do it the first time.
Yeah, once the initial payback, return on investment comes in, you best believe it will begin basically this will initiate that space race. Once one company makes just a huge return on investment, everybody's going to be trying to get out there. Everybody's going to be trying to plant a nanosat on a meteoroid and
Make
get
all
those.
sorts of incredible things out of
Exactly.
it. Yeah.
And one last thing I want to close out on, in terms of, okay, great, so we'll make a lot of money, we'll get a lot of materials, but a lot of people who are into space for space reasons like us, the same technology that we're going to be using to extract these materials and potentially either bring an object closer to us or knock it into the moon's orbit, these are the same technologies that are eventually going to save us from our Armageddon moment. While we won't have Bruce Willis on our side, we will definitely be able to, hopefully avoid the next cataclysmic event by deterring an object that could
We have to do
cause
that.
some damage to us.
Yeah.
Well, the one
Sorry,
way that we're going to get
that's
closer to that future is by reducing our cost of launch. And Space Mike,
That's right.
that's what you're going to talk about for us now, right?
That's right.
Which group are reducing our cost of getting to space?
So competition is a great thing that is able to reduce costs in any markets. And China has had quite a few launch startups, as I mentioned in the open. And I mean, there's over 60 startups now, but there's 5 specifically that are doing rockets that I want to talk about, some of which we've talked about a little bit on the show before. The reason I definitely wanted to give a rundown this week was because 2 of those companies launched suborbital rockets this week. And I didn't want to cover that in the launch minute, but...
Quick a 10-second comparison between suborbital and orbital?
So suborbital is just a parabolic arc that'll go past the Kármán line. So you are technically in space, but you're not fast enough to go in orbit around the planet. You'll just go up, have microgravity for a couple of minutes, depending on how fast you are going, and then you'll come right back down in a parabolic trajectory. But orbital is where you're going fast enough to actually be able to orbit the planet. So these two suborbital launches did not go into space. One of them actually, there was some media reports that it did go into orbit because it actually had 3 payloads on it. And that was actually a launch from a company called iSpace. They have a single-stage solid-fueled rocket that was just a technology demonstrator. This is basically the first stage of what they're eventually going to have. And they're calling it the Hyperbola 1Z. This is the launch of it right here from the Jiuquan Satellite Launch Center. And this launched at 500 Coordinated Universal Time on Wednesday. And it, like I said, it had 3 payloads. One of them, Erebus-1, parachuted back to Earth, and then the other 2 were recovered with the rocket later. And again, none of those payloads entered into orbit, but it was still interesting and you know, a test that they needed to be able to see if they could actually do it. But just 2 days later, I mean, on Friday, another company that I've talked about before called OneSpace launched another of their demonstration rockets. And this was the OS-1X. And again, it was like this last test. It was just the first stage of their eventual rocket.
Oh, that's loud.
But it was successful, and there wasn't. We didn't have some warning for this as well. This also launched from the Jiuquan Satellite Launch Center at 4:10 Coordinated Universal Time yesterday on Friday, September 7th. And there is a view that they got of this launch that is pretty amazing. One of the Jilin-1 Earth observation satellites that are in low Earth orbit right now that belong to the Chinese Space Agency were able to take a view of this launch from space. And
Wait, does this mean that they specifically lined up their launch window of the suborbital rocket to when that one was going overhead?
That's right.
What? That's crazy.
That's right. Yeah, and you can see right here, and the trajectory for it wasn't going straight up either. They wanted to kind of see doing a test of the type of angle. It's almost more like an ICBM trajectory where you would be trying to go to an intercontinental ballistic missile. But this test was also successful as well, and so I'm really excited for them. There's also another company called Space that is doing something really interesting. They are doing tests of a reusable rocket, and they have tests that are similar to what Maston Space Systems has been doing for quite a while. And they eventually want to have a rocket that's smaller than the Falcon 9, but looks really similar, and the first stage would come down on boosters. And so they
cool.
I believe that we have a video here of one of their tests that they have, and I really like that with them they just have the small startup team, whereas a lot of the other companies have been working with the Chinese government before, and I'm just blown away by some of the progress that they have. There's so many companies, though. There are so many companies. There's another company called Landspace that's doing another solid rocket. There's another company called Xpace, EXPACE, that's doing a solid rocket. Check out this test, though, this hop right here.
Wow, it's very Maston, isn't it? Awesome. Are these all private companies, or do they have Chinese government financial backing to make them successful? How does that work?
Well, they are a little bit of both.
Can you even have private companies in China?
Yes, and they are getting private investors, most of whom are in China, but some of them are outside of China as well. OneSpace, actually, some of their donations were actually from outside China. They were actually coming from Europe. I don't know if they could get any investors here in the United States. I don't know how that would work.
Issues?
Probably, maybe. I don't know, though, because there have been several other Chinese companies, and there's tons of American companies that have factories in China. So as far as it's a business thing, I don't know. I'm not sure. That's a good question. However, there is cooperation too with the government. These launched from one of the official Chinese launch centers. Had a Chinese satellite, monitoring one of the launches of that. So there's lots of cooperation going on there. And again, the whole purpose and the whole point of this is to bring launch costs way down.
Do we have an idea of what kind of prices we might reach with these companies?
Oh man, well, we do have an image of Space's rocket. This is called the New Line 1, and this is eventually what they want to have. This is what I was talking about, the kind of smaller. It has 5 engines explosions at the base there. So you could almost call it a Falcon 9. I'm not sure, but they've been marketing that for, it's around $10,000 per kilogram. So it really depends on what your payload is. But yeah, I mean, that's quite a bit. I think the max that they can do for this one is around 500 kilograms for a large satellite. So I mean, let's do the math there. What is that? That's about, is that 50 or is that $5 million? Sorry, I'm tired right now.
I can't do math on air.
Let's see. That's
I'm sure the chat room will inform us of that one.
yeah, that's about 50. So.
Yeah. Cool.
All right, but yeah, this is going to bring the cost way down. And as more of these companies, as they're competing with each other, I mean, first they're going to be trying to compete for just the Chinese market. And then as they are successful and have full orbital class vehicles, they can compete on the international market as well. I mean, China's already launching commercial launches on their Long March series of rockets. So, I mean, this is just going to push everything further and further down and force a lot of the launch companies around the world to innovate.
Yep, totally. You've got to reduce your cost, otherwise that's what competition is all about. So go China.
Yeah.
Thank you very much, Mike. Now, Jade, your next story is about lunar swirls, which when I first read this, I was like, I don't even know what a lunar swirl is. So please enlighten me.
Okay, first of all, I'm glad I wasn't the only one, because we're all very familiar with some of the more prominent features on the moon's surface, like the mare and craters, things you could actually kind of just see with your naked eye. Lunar swirls are things you could see with a pretty basic telescope in your backyard, but when you look at them, they're actually really pretty. Dada has this photo that he's going to show you. And as you can see, there are these very whimsical, swirly little features on the surface, almost reminiscent of like a Van Gogh painting. But up until now, these features have actually been pretty mysterious to scientists because they weren't really sure what caused them. You see, when you have mare, it's like, okay, that was caused by ancient lava plains. Oh, you have craters caused by impacts. But then these little fellas are kind of more mysterious. And recently, there was a joint study done by Rutgers University and UC Berkeley, right up north, and they actually may have found out why and how exactly these little guys exist.
Okay, so why?
Why do they exist?
Why lunar swirl?
What have we discovered?
If it's not lava, then what is it?
So it has to do with magnetism. So the lunar swirls themselves are caused by the lack of weathering. As you can probably, as you can see from the last image, you know, some areas were brighter, some areas were darker, and these swirls are characterized by localized magnetic fields. And the magnetic fields actually detour solar winds. So there's less weathering in these areas, hence causing those really pretty patterns. But the question has been, what's causing those magnetic fields? How
Does
are they
the
there?
moon itself have its own magnetic field like the Earth, or is it a different?
Not anymore. So actually a recent study done was shown that yes, the moon was once magnetic, geologically active, had a magnetic field and everything, and actually that magnetic field lasted longer than we previously thought. And that leads us into the potential explanation as to why these swirls exist. So there was a mathematical model devised by a few scientists, including the image of this young lady right here. And she's actually studying moon gravel, moon rocks, just very tiny pieces of it. And they devised a mathematical model that essentially surmised that lava tubes and lava dikes exist right below the surface of these swirls, and they're very magnetic. But the question posed itself, well, how are they magnetic? How it's, you know, lava. And what's interesting is what they did was they basically imagined that you were on this environment up to 3 billion years ago when the moon was quite young. And basically, this is an environment unique to the moon at that time. And essentially is you have these very strong magnetic fields, and you also have really hot temperatures. So what they found was that when you take lunar rocks and you superheat them to, I think, over 600 degrees Celsius, they actually do give off, or they become highly magnetic because basically minerals break down and they release metallic iron. Metallic iron combined with the strong magnetic field of the moon means that everything is going to align in the same direction, causing a very strong field. Now, obviously, this wouldn't be able to happen on Earth because the iron would just bond with oxygen, become oxidized, and the moon now doesn't have a magnetic field, so that wouldn't necessarily happen now either.
Or oxygen as well.
Oxygen, right? Yes, exactly. And so essentially why this is important is because these are features that you can literally go outside and see. Like I said, with like a basic telescope, you can look at these swirls like...
There's a question here in the chat actually from Trebles. They ask, how big should my Dobsonian be to see the swirls?
That's a good question. I'm not entirely sure of that figure off the top of my head.
Dobsonian, is that a telescope? What's a Dobsonian?
That's the one.
Yes.
Yes,
Okay,
it is.
yes.
And so I don't know the exact aperture or anything of that or the power, but essentially you would be able to see it with. I mean, I was looking at amateur astronomers and some of their images of it, and it's really, they didn't have anything too crazy or too expensive.
Awesome.
And future missions will go up there. Future lunar rovers could go up there and study it, more extensively to find out more about these dynamics. But it's just interesting because we think we already know so much about the moon, but there's still so much to be learned. And kind of a throwback to last week's show, if you want to check that out, we also talked about the moon and how we have a very intimate relationship. Obviously, it's our moon. It was once a part of us. But even now, we're still learning all of these new things about it. And I don't know, personally, I just thought it was really cool that this is an anomaly that's completely unique to its setting and the time that it was formed. And you cannot recreate it now.
Well, something else I find really interesting is that there's a lot of studies for if and when we colonize the moon or start setting up bases on the moon, that lava tubes is the ideal location for a lot of people because you could easily protect yourself. And it makes me wonder if that magnetism you could utilize that. Like, I don't know if you could be able to heat it up with some sort of habitat. That might be pretty expensive, but I wonder if you could help give yourself a little bit of a small magnetic field. Yeah.
Absolutely.
We could start a business. We could melt them down, get magnetic rocks, and then make compasses out of them, send them back to Earth, and there you go.
Launch it on a Chinese startup. There we go.
Yeah.
Oh, wow, it all comes together, doesn't it? Here tomorrow.
Oh, all right. We are going to take a very short break, but before we do, we would like to say a very, very big thank you to all the supporters, our citizens of tomorrow that help make these shows happen. Specifically, our Escape Velocity citizens. Thank you so much. These people contribute $10 or more per episode, and we could not do the show without you. If you would also like to become a citizen of tomorrow, head over to patreon.com/TMRO. All right, we're going to take a quick break, and when we come back, Jared has an interview with NanoRacks.
Look into her face, determination in her eyes. She won't give up or quit or fall for little fashion lies. Filled with awesome expectation, this girl's a fascination. And nothing in her way will keep her from her destination. Cause she's fire walking, she's fire walking. When it's hot, she keeps on moving, for the heat keeps on improving. Yeah, she's fire walking, she's fire walking to be free.
Hello and welcome back, everyone. We are here on the Observation Lounge at Station 204, and I am so excited because we have the Chief Technology Officer, Mike Lewis from NanoRacks here today. Welcome to tomorrow, Mike.
Thank you very much, Jared. Pleasure to be on your show.
All right, so we're just going to go straight into it because we have a lot to cover with NanoRacks and the work that you guys do. So tell me a little bit about NanoRacks for anybody that may not be familiar with your company.
Yeah, so we're an interesting company. We're a fully commercial company that puts things in space. We specialize in scientific projects, educational experiments, and things like that. Basically, we make it easy to put things on the space station or other platforms so that scientists and researchers don't have to focus on all the paperwork and stuff. So we found this nice little niche and a nice way to actually do business in space. So we're recently celebrating a couple milestones. We've flown our 700th payload to the space station, which is a big deal for us. And I had a sticker made, so it's official.
Nice.
Yeah, thanks. It signifies a lot for us. Back when the space station was made available to commercial researchers and was designated a national lab, we took advantage of that. And since then, we've been about half of the allocation for the national labs that goes to the station. Unique company. We do a lot of experiments inside the space station. We're also known for satellite deployment. We have satellites that we deploy, mostly CubeSats, off of the space station. We also deploy slightly larger satellites. We call them Arcaber class satellite, but it's for those familiar, it's about an ESPA class satellite. We also deploy satellites off of the Northrop Grumman vehicle, the Cygnus vehicle, at an altitude above the space station once it's done with its primary CRS mission. So to date, 223 satellites, 700 payloads, and we just keep kicking butt and rolling. So.
Excellent. So can you tell us a little bit about your background and kind of how you came to work for NanoRacks?
Yeah. So I also consider myself an amateur aerodynamicist, Jared. So I forgot to compliment you.
Yeah, we're both on point today. So. Yeah,
awesome. No, I come from basically a background of aerospace. I went to school for aerospace. Went to grad school at the University of Colorado in bioastronautics. I worked for a small company in Seattle called Tethers Unlimited. They're becoming known in the industry, a very research-based, super fascinating company. And then I moved to Houston. Moved down here and did a little time in the oil field, actually, and found a lot of similarities in that, and then joined NanoRacks as a contractor. We developed very organically, and then as a full-time engineer, and shortly after took over as the CTO. So I've been in that position for a number of years now.
So before NanoRacks, was there anyone that provided the same services that you do on the space station, or were you guys sort of like the first ones to come and step up to the plate?
Now, in a lot of ways, we've been a pioneer or a forcing function in this industry. Before, it was possible to get things into space, but as many people know, many researchers know, it's a difficult, long, arduous process. The NASA system is designed to be very cautious and safe. We have people in space, so we have to take extraordinary caution, make sure we don't hurt them or the spacecraft. So before we came around, you could get things to space, but it was often only research institutes or areas of higher learning or NASA centers that were able to put experiments on the station. We filled a unique need, I think. We identified this difficulty and said, well, you know what? Let us do it for you, and we'll act as the intermediary. So what's been great is that we've had incredible support of NASA, primarily. NASA's aware of the difficulty that their system has to get things to the station, so much that actually NASA is one of our customers. So they very often researchers at NASA come to us to get their experiment on orbit, instead of going through the traditional channels.
Oh man, that is so cool that you're helping out NASA, but also NASA goes to you, and it kind of seems like it's a relationship that goes both ways. You're kind of helping out each other.
It's interesting. That's a fine point. NASA wants us to be successful, and they want everybody to be successful. And early on, we felt a lot of support, and still to today. But it's a funny space, pardon the pun, to operate in. NASA wants us to be so successful that we create competitors for ourselves, and we've seen a lot of very successful companies come up that are doing similar things, and it's created this competitive environment in space.
Yeah, and actually to kind of talk a little bit about that competitive environment from our chat room, Trebles is asking, are your launches guaranteed, or do you have to compete with other entities that want room on a launch vehicle?
Great question. So when NASA first designated the space station a national lab, they allocated half of each of the CRS, the crew resupply vehicles. The half of the cargo is for the national lab. So that means that my company or any company that has a Space Act agreement with NASA has access to that space. So we definitely, we're seeing more and more science experiments take up that space, and we have to fight for that. But to date, we've worked with CASIS, the Center for Advancements of Science and Space, and with the particular divisions at NASA to be able to get everything on orbit. Another unique thing about the space station, CRS missions, and our company in particular is that if a science experiment can't make a particular launch, we can always just move them to the next launch. There's there's the SpaceX vehicles, the Northrop Grumman vehicles, pardon me, but also the JAXA vehicles, the HTV, and Russian vehicles that are going to the space station, and if the experiment can't make it for whatever reason, if it's full or if the science just wasn't ready, we can always move it to the next launch.
Very, very cool. And I just kind of want to ask, like, what are the kinds of payloads that people will send up? What's the kind of stuff that you at NanoRacks are able to enable on the space station?
So people fly all kinds of stuff. It's incredible. So even you'll see stuff from basic science, like growing sugar crystals in space or things like that, to super advanced scientific experiments. Actually, one that I'm actually very proud of was we flew the first Chinese experiment to the space station. It was groundbreaking in a number of ways, but that experiment involved DNA replication and how the radiation environment of LEO affected that replication. So it's all across the board, from basic science to our satellite programs. They're doing Earth observation, boat AIS, just extremely advanced things.
So we've got a really cool question from CFIT in our chat room, which is asking, what is the percentage split of customers, university, commercial, other, and has that been changing over time? Is one of those growing faster? Kind of how does that run for your customers?
It's a great question. So we see the majority of our experiments by number are educational. They're coming from universities, coming from really even down to elementary schools. We have a number of programs, and we've actually spun off another company just to do educational things called Dream Up, and that's the majority of our payloads are these educational things. So we see them out of universities and things. Following behind that are commercial. We flew the first 13 versions of the Planet Lab Dove, which is the Earth observation satellite that's now operating as a commercial company. So we were able to enable that. We also see a lot of other experiments that fall somewhere in between, something where somebody has a research grant and they're able to fill in the last bit of money from an agency like CASIS or a DoD agency or something like that, and they're able to fund this. What we're seeing is just access to space is becoming increasingly more available, and people aren't as hesitant to fund experiments that are going to the space station.
And Henny Zvorwerp in our Twitch stream is asking about connections with launch providers and filtering the requirements. Do you guys do it? They're sort of asking in English to people who need to get things to space. So I guess, do you guys have a very simple kind of way that you get payloads from folks, like a very simple amount of requirements?
So one of the biggest challenges that researchers face to getting things to space is understanding which requirements you have to fulfill and who you have to, who's that requirement owner, who's the subject matter expert at NASA, and all these things, and it's overwhelming. So we do that. I have a team of 8 and growing that are dedicated. We call them mission managers. These engineers and other backgrounds are the people that act as the in between. So they go to the say somebody brings a slime mold experiment to you and they say, I want to put this in space. So one of my mission managers will say, okay, tell me all about it. Teach me about everything that's going on with you. Tell me what your science goals are. Now tell me what could be dangerous about this. And let's change your experiment slightly, or let's change the way that we put it in a box or something like that so that we can make it safe and comply with NASA. So we act as that interpreter, to put it into plain English, so that we can get that experiment to space.
And to kind of talk a little bit about those experiments, we've got 2 very similar questions from our YouTube chat room from Luke S. Van Hout and Mac Malkowai, which is, do you ever have to deny a science project? Are there experiments that you have to refuse, like CubeSat propulsion, laser comms, lithium batteries, other things like that. What are sort of like the big red flags? Like no, you can't take that. We even have where was it? Oh yeah, in our regular chat room, Treble's asking, as a private citizen, can I send up some random stuff like kids' toys, or do I have to have a research purpose?
So these are both great questions. I'll answer Luke's first. So we have had things turned away, but it's mostly things that are ceremonial or something like that. We haven't. You can't fly human remains and things that would just be like a religious icon or something like that. Pretty much everything else we've found a way to fly. We've flown, blood experiments and plants and animals and everything like that, and it can all be overcome if it has legitimate science. So to answer Mac's question, could we fly trinkets? And the answer is yes, with an asterisk by it. If it has an outreach or educational purpose, we found that if we fly a whole bunch of, say, I don't know, stickers and we put them up in space, that there's no real scientific value to that. So if we take these stickers and we make it part of an educational curriculum that teaches classrooms about space, and at the end they get a sticker, that's something that we can do. So, if we fly a Lego guy, he's got to have a purpose. We can't just fly him just to go to space.
Gotcha. All right. So unfortunately, my collection of my Lego Saturn V at home, I can't stick that in a NanoRack and fly it. Gotcha. Mini Stoge in our chat room is asking about what kinds of checks and tests are required for payloads. Since they have to live near people, what's unique about flying a payload inside of the station?
Great question. So that's the primary goal, is to keep the astronauts and the space station safe. So we can't hurt anything. And, an experiment could have a bad chemical in it. It could have, sharp edges, things like that. So those are the things that we address. Not to say you can't do any of these things. So we fly a lot of bad chemicals to space, but we make sure that they have proper containment. Say you were flying some, I don't know, I won't make it up, but a bad chemical, we'll put it inside multiple levels of containment. In case one breaks, then you have the next. Sometimes that level of containment is as simple as a Ziploc bag. Sometimes it's a complicated mechanism that has, very complex valving, and it itself is inside of another enclosure. Beyond that, we make sure that things can't go off accidentally. Luke's question a couple back, he asked about CubeSat propulsion. We've actually successfully flown CubeSats and other satellites with propulsion. We just have to show that it won't turn on and one, hurt the astronauts when it's inside the space station, or two, won't turn on uncontrollably and come back and hit the space station. So those are some of the challenges. Beyond that, we have a human factors requirement. There's some folks over at NASA that come over and they'll check out each of our experiments and make sure that there's no things like sharp edges, and that if there's an astronaut's going to interact with it, that their tools all work, and that there's not anything that's going to interfere with that. Hey, there's our Chinese Chinese experiment. That's out of the Beijing Institute of Technology right there. That's the first Chinese payload in space on the space station.
Wow, that is awesome. Because I know there's usually restrictions and things with NASA working specifically with China. So do you have to follow those restrictions, or are you able to sort of open up to anyone who may want to fly a payload on the space station, as long as it's like scientific or something?
Yeah, so a couple answers to that. One, with the Chinese payload, it did actually take a literal act of Congress to get that up there, and we had some different types of challenges to fly that. Basically, that experiment operated completely disconnected from the network. So the space station's like any other building or office where there's Wi-Fi and there's Ethernet and things like that. And this experiment was completely disconnected from that. Just used power. It was an autonomous experiment. This one was unique, though. Most experiments we're able to plug in and do real-time communications with them, do data collection. We can operate from the ground. And actually, I'm in Houston next to Johnson Space Center, and in my office building, I have we call it the bridge. I have a command and control center where I'm able to control experiments from the ground, from my office. And the reason we're able to do that is because we host these experiments inside of our platforms that have already gone through all the verification process and have been shown to be safe to the space station.
So Trebles from the chat room is asking, do the experiments have to automatically run, or do astronauts start the experiments? Or can they even come in and do things for the experiments to like change parameters or things that a scientist may want?
So both. It's one of the unique parts about having the space station is that we have astronauts up there, and we take full advantage of them. We, astronauts are well trained, extremely particular engineers and scientists up there. So we have them do a lot of things. One of our simplest experiments is called a mix stick, and it's a tube that has different types of either chemicals or growth compounds or bacteria or things in there. And we have the astronauts interact with those. They open up a valve and they'll shake it. They'll be in space and they'll shake that for us, and they'll take observations and send them back down. The opposite of that is we have facilities on station where we don't have to use the crew. Very often you'll hear that the crew time is limited. And it's very true. Not only am I asking them to do things, but everybody's asking them to do things. Everybody who's doing science in space. So there's a real advantage to being able to plug in an experiment, and then we control it from here, from my command and control operations center.
Very cool. And Handy Zwarwerp on our Twitch stream is asking, is it difficult to get on board with a new launch provider, like when Blue Origin or something starts flying? Do you already have a working relationship? And I think you guys do, if I recall correctly.
We do. Yeah, that's a great question. It's really insightful, actually. So we have a relationship with Blue Origin. We fly the researchers and scientific investigators throughout the world can fly things on this through us. We are their payload integrator. We make sure that their payloads are safe, and we actually integrate them into the space vehicle, the New Shepard out in West Texas. We also have a number of facilities. We call them facilities, but things you can plug experiments into on that capsule, including an analogous system to the one that we have on space station. So what we're seeing is a lot of researchers will do an experiment suborbital, check it out, make sure it works, and then buy down a lot of the risk, and then fly the same experiment or version of it to the space station. And we've provided a commonality that's cross-platform for both those applications.
And a question from our chat room from Trebles. Trebles is on it today.
Trebles is on.
Yeah, Trebles, great questions. And this is so cool about our chat room. We've always got great viewers with great questions, and we really appreciate it. So they're asking, do you offer both pressurized and depressurized environments, or are they all the same?
Yeah, and Trebles is on it. So a lot of the stuff I've been talking about has been inside the pressurized volume of the space station. Experiments that are meant to purely take advantage of the microgravity environment. We have an entire other product line of things that go outside. And we showed a picture earlier, and I think it's over my shoulder too, this guy. We have the NanoRacks external platform, the NREP. And that's in the unpressurized vacuum of space. It's a spot where you can bolt on experiments, and we provide power and data to it. So we're coming up on our 5th mission of that. It's located on the outside of the Japanese exposure facility, the EF module. We call it Legoland for another Lego reference. And that's a great spot to do experiments in the vacuum of space. This picture that you guys are seeing now is our NRCSD, the NanoRacks CubeSat deployer, and it's shown deploying a 6U, which is a 60 centimeter total, so it's a 2x3 CubeSat out of our deployer that's attached to the Japanese robotic arm.
Wow, that is so cool.
I think that's the Radix satellite. I think I'm having trouble seeing it, but yeah, so that's also in the unpressurized volume of space, and that goes into orbit and operates for about between 6 months and 2 years.
Yeah, and to kind of ask a little bit about things going on orbit, Handy's Vorwerp on our Twitch channel is asking, is there a certain time limit that something can orbit, like a project has to deorbit in a few months? I would imagine at the space station's altitude, usually atmospheric drag would take care of things with that pretty quickly.
That's very true. And, a lot of our satellites see a lifetime about 6 to 8 months, just because, we don't think about it, but at that altitude, there's a relatively high amount of particles. And so, through drag, they end up deorbiting, which is why, we actually explored this other program where we take we worked with our friends at Northrop Grumman to put satellites on the outside of the Cygnus vehicle and actually go up higher. And what that does is when they deploy at that higher altitude, they last a longer time just by the nature of the orbital mechanics that's going on.
Yeah, and to kind of piggyback on that, Next Space Flight is asking, do you plan to use your CubeSat deployers on orbital launches other than International Space Station resupply missions?
And yeah, a great audience here. The questions are incredible. Yes, definitely. So we're already using it on the Northrop Cygnus vehicle, and we've done 4 missions on that, coming up on our 5th, where we deploy above. We also have deployers on other vehicles, non-space station related, and we're looking at the future of this as being able to provide payload access to both the Gateway and to lunar orbits and surface.
And Troubles from our chat room is asking if and when the International Space Station is retired, are you planning for other ways to get experiments into space? Yeah,
definitely. So we actually have a contract with NASA. A little while back, NASA realized that they better start looking at what's coming up next. And this contract is called the Next Steps program. We were one of 5 awardees of this, and that's exactly what we're looking at, is what do we do next? We actually have a kind of unique approach to this. We're looking at reusing parts. So specifically, every time a rocket goes up, there's an upper stage attached. Say a satellite's going to launch, it has the primary stage, and then there's a secondary stage, like a Centaur, if you're talking about an Atlas V. And we're looking at whether or not it's feasible to take that and actually make that second stage into an orbiting platform, into its own space station. So that's currently in work. We're checking that out. We're also looking at some other upper stages just to see what can be done. But it's a great question. Like we need to have a presence in space up there. As we've shown, it's a place to do business. There's a need for commercial platforms, and as the space station starts winding down and NASA looks towards the Gateway and towards other ventures out there, they're going to look to commercial companies like mine to take over low Earth orbit, and that's how we're going to do that.
And Hanny's Vorwerp on our Twitch channel is asking, what trends do you see happening in space based on what you're currently launching?
Cool question. I'm seeing a lot of really cool stuff happen. I'm seeing generally a lot more success. When we talk CubeSats, it used to be that just about 30-40% of them just didn't work. They were dead on arrival. And what we're seeing now is that more and more are working. It's very rare that one doesn't work. It's wonderful. We're also seeing the higher fidelity of experiments in the pressurized volume. I attribute that to Moore's Law, but also the fact that everybody can get a Raspberry Pi or a BeagleBone or any of these Arduino platforms, and everybody's programming them. So the fidelity of experiment we get when it comes to us is much higher, and we're able to do a lot more with those experiments. So I think generally the trends we're going to see more experimentation, higher throughput, higher in. For the scientific researchers out there, and really we're going to see some really good stuff come out of that.
So you guys have a CubeSat deployer up on the International Space Station, but you guys are also working on an airlock module. Is that correct?
Yeah. Oh, yeah. Thanks for the reminder. So this is, yeah, we're extremely excited about this. My company is building the first truly commercial element of the space station. Similar to how Bigelow built his expandable module, we're actually building right next door to that. It's a commercial airlock. It's a commercial science airlock. A couple years ago, we kind of identified a need. This shown in this picture here is the Japanese airlock, and you see we've got a big satellite on there. That's the Kestrel I, the KE-2M satellite on there, and that just about maximizes the volume of that airlock. Now, just for reference, that's about the size of a dorm fridge, and in that like 50 to 80 kilogram range. So we said, well, you know what, we need something bigger, and we figured out that there was this port available, and we said, hey, NASA, can we have that? We don't want any money, we just want access to it. And they said, yeah, go ahead. So I got terrified and had to scramble and design and build an airlock, and it's still in process. We're right on schedule. It's going to launch on SpaceX 19, which is in the fall of next year, and it'll be operational shortly after that. And it's going to be another way it's going to be another gateway to space for research platforms.
Mm-hmm. And you said that quite a few of your customers are educational. And we know that there's lots of colleges and universities that fly CubeSats. But you also mentioned that there's sort of regular schools, like before you get to that top level, that also fly CubeSats. What kind of stuff are they flying, and what does that sort of do to them educationally, that they can fly their own payload on the International Space Station into space?
It's amazing. So one of the things that we're really proud of is the fact that we've enabled science to happen in a school year. It's kind of unprecedented, and a lot of the programs that we have are just aimed at that. Our mixed programs or our NanoLabs, where in the classroom they can take an experiment from just conceptual phase through the design phase and launch it and see it operated in space within one calendar school year, which is amazing. You would think you'd get just kind of a lot of the same experiment or things like that, but it's actually the opposite. We're seeing just these incredibly innovative experiments come out because it's coming from young minds that haven't been jaded and shut down so much. Shown here is the hydrofuge. This is out of Lakewood in Colorado. NASA Hunch program sponsors that, and this experiment's a great example of that. It has a centrifuge that's used to, so it's a plant growth experiment, and once the plant is watered, what happens in space is the surface tension of water keeps it bound on the roots of the plant. And this hydrofuge experiment actually spun the whole thing and flung the water off so that it wouldn't rot and get moldy. So it was a brilliant experiment. And they continue to do great work over there. So NASA Hunch in Lakewood. It's excellent.
That is fantastic. And I think our final question that we'll take from the chat room today is from CFIT, which says, personally, can you say what was your favorite mission so far and why? Which of these 700 has interested you the most?
Yeah, I love them all, right? No,
can't pick one.
There was an experiment that was flown out of a local school here in Houston, and it involved slime molds, and it just fascinated me because I had no idea what a slime mold was, and it made me look into it and research it, and if you have the time, look it up. It's fascinating. They're they operate as single cell organisms, but then they come together as a team and they become a bigger organism. It's really, there's a lot of metaphor there, but it fascinated me, and these kids were not only experts in slime molds, but they had designed an experiment to see how they would operate in zero gravity. And that one really just sticks out to me because it was just this, I had never thought about it. And, and here I am enabling that science in space. It was wonderful.
That is fantastic. Mike Lewis from NanoRacks, thank you so much for coming on the show today. You guys are doing amazing work enabling just about anyone who can to get their payloads in space. So thank you for coming on.
I sure appreciate Jared. I appreciate this time. I'd like to say thank you to also Space Mike, Lisa, and Jade on the front end there. And if anybody's interested in learning more, go to nanoracks.com or to dreamup.org. We're hiring. So if you're interested in coming to space, send us your resume.
Yeah, and before we officially wrap up this segment, I do want to ask you a set of standard questions that we try to ask every guest. We've been asking them in After Dark a lot lately, but I figure we'll just go ahead and do it right now. There are no right or wrong answers for these questions. It is simply just your answer for it.
Okay.
So the first one is, what is your favorite space mission, past, present, or future?
Oh, favorite space mission. Oh, goodness. You could look back to anything. Alan Shepard, it just jumps out. The Apollo missions, things like that. I'm going to give you a lame answer. I'm going to say my favorite space missions are the super boring ones, the ones that go very well without event, don't even make the news. I like that. I want space to become more normal and routine and everyday.
That's not lame at all. That's like the goal. So, that's aiming high. So our second question, human or robot exploration of the cosmos?
Both, of course. Robots for a lot of things. I think, as part of our Next Steps contract, we're looking at robotics. We're working with SSL, MDA, SSL, Altia Space Machines, all these like leaders in robots. It's necessary. There's certain environments that you just don't want to put a person in. If you're gonna be cutting metal in the vacuum of space, you want a robot to do that. But ultimately, we want people in space. It's what engages the public. It's what it fascinates us, but it's also where we're going to get the most value, I think. We're going to learn more about the human body by having these, having this experimentation in this wonderful laboratory, and it's going to provide the biggest benefits for those of us on Earth.
That's awesome. So our third question, where should we go next? What's the next destination?
Well, sounds like we're going to go to the moon. Deep Space Gateway is on. The BAA just came out for the first element of that. I'm excited about that. There's an RFP out for lunar exploration. I'm excited about that. It makes sense. There's a part of me that wants, and you're an astronomer, so you understand this, wants there just to be a signal that comes in and just says, hey, we're out here. And suddenly we have a destination. It'd be incredible. All of us in the industry, everybody who's aerospace would suddenly become rock stars, right? Which is great. Yeah. But also we would have a purpose and drive, and I would love that. But till then, let's explore the things around us. Let's learn more, and let's get ready for if that ever happens.
And our final question that we ask, which also happens to be my favorite question, is why space?
Why space? You mean personally?
Yeah, well, however you want to answer it. It's up to you.
Why space? Well, because it's fascinating. It's the next frontier, of course. It's where it's what lies beyond this planet. For me, I like space because it's challenging. It's analogous to the early explorers that got on a boat and they just had just the things that were on the boat. There's that sense of adventure and that, kind of, human desire to see what's beyond the horizon. So that's what I like about it.
All right. Well, thank you so much, Mike, for coming on the show today. This was fascinating. And like we said, this is just such great work, especially to hear about it directly from you guys. So thank you for coming on.
Sure appreciate it. And thank you, guys. Thanks to the whole team. Making tomorrow today.
Yeah, there you go. And also, we have to thank you, the viewers, as well, especially our viewers of this escape velocity variety, you folks give us $10 or more per episode, and you get some really cool stuff with that. But we also want to thank our orbital citizens as well. You folks give us $5 an episode or more, up to $10. And without your help, we would not be able to make this show happen. And that's not overstating it either. It really is one of those things where you folks enable this to happen, and we are ever thankful that you folks have decided that we are worthy of that enabling, and we cannot thank you folks enough. I mean, I can't. I'm literally thanking you like 20 times in this time right now. So if you'd like to help us out, you can head on over to patreon.com/TMRO. And we're going to now head off to break. And when we come back, your comments from last week's show. So stay tuned. There's more tomorrow right after this.
Look into her face, determination in her eyes. She won't give up or quit or fall for little fashion lies. Filled with awesome expectation. This girl's a fascination, and nothing in her way will keep her from her destination. 'Cause she's fire walking, she's fire walking. When it's hot, she keeps on moving. Through the heat, keeps on improving. Yeah, she's fire walking. She's fire walking to be free.
I'm sorry. I thought I was out.
Cameras were off anyway.
Where did Jade go?
Oh, man. Oh, is that yours?
Why
No,
am I
that's
here?
yours.
Oh,
Okay.
Oh, whatever.
Doggone it. I'm
That's
sorry.
okay.
I didn't realize I was sticking.
Oh, jeez.
Jared, we do it the same every week.
Yeah, but there's 4 of us, not 3.
Wait, if we're already
Throwing
going to make
things
it,
off.
do you want the table more that way, Ben?
So if I were to center up the camera nice and neat, this is centered camera, and so actually
pretty
the
good to
table
me.
needs to go that way, ever so slightly.
Okay.
That way. That way.
Like
Yeah,
there?
Yeah, because Jake, we've got too much.
Jeez.
Yeah, there. Okay, now, Jake, you need to go this way a little bit.
This way?
Yep, there you go. Jared, sit. I don't know what you're doing, Jared.
Sit down, Jared.
All right, now you look.
It's leg
does that
day.
look- I've got hashes on my screen. How's that look to you, Bella? Good? All right, let me just do a quick little magic
Welcome to the show.
behind the scenes.
That was a great interview.
Thank you. Yeah, that was, I mean,
This whole show has been great.
Thank you, Hanny Vorwerp and Troubles, for all your great questions.
yeah, just literally like crushing it out there.
Unicorn war paint.
Welcome to How It's Made with Tomorrow.
Yeah. It's not as pretty as you think it is. So that's for sure.
Reminded me of like True Hollywood Story with the camera angles and the blurry to the clear to the zooming in. Is that the feel you're going for, Ben?
Yeah, that's exactly what I'm going for.
Okay, cool.
I have not seen Ben give a look like that in a very long time. So that was good.
It was the look of pure pride, and I'm so
Okay.
proud of you, right?
And thanks for sticking with us. Now we're going to get into your comments and community interaction from the past week. But our last show was with Dave Maston, and we talked about lunar landers. So if you didn't check that out, go back and watch it, because any show that we have on Tomorrow with Dave Maston is a really good show. They're working on some amazing stuff. They're going to the moon. They fly and they get stuff done. So go back and check out Orbit 11.34. It was a great episode. But our first community comment for today comes off of YouTube from False Eve. And they say, the risk of debris impact compromising cabin atmosphere is represented as probability of no penetration, or PNP, and is defined as the probability of not sustaining a critical penetration over a 10-year lifespan of ISS. The PNP changes with vehicle attitude and its corresponding cross-sectional area with respect to the velocity vector. For the 15-year lifetime of the International Space Station, there's a 48% risk of penetration. The chance of station evacuation due to a more devastating meteoroid or debris collision is estimated at 15%. 15%.
Yowza.
That's, yeah.
So this is in reference to the debris impact that we kind of had
Right,
last week, right?
right, yeah.
Wasn't there some updates?
There have been some updates. In
Yeah.
fact, it's according to Roscosmos and Dmitry Rogozin, it was not a debris impact. Apparently, this was done on the ground before launch, but it was not done at Samara, the manufacturing plant where they manufacture the Soyuz vehicles and the Soyuz rockets. This was done at the Baikonur Cosmodrome when it was going through its final checkouts. And apparently, someone accidentally drilled this hole and tried to cover it up with glue or some sort of epoxy. And that material that they tried to plug it up with came loose, and that's what caused the leak to start.
Yeah.
So, this is what this comment is referring to, was that whole debris and that whole scare, I guess, at the International Space Station. And the astronauts were fine the entire time. It was a very, very small, minute leak, and they found it and patched it up.
If you look at the photo of the actual hole, there's like a part where a drill bit kind of scattered across
can
the
see it.
surface. And I figured that's what that was immediately after seeing it, because I've done that plenty of times while helping build the Tomorrow set. So that's how I learned
leaks right
that,
now?
that was a drill hole, and then oops, while still running with the drill across it. So thank you for that, Dada,
hang on.
teaching me that. So
Yeah.
If this is from the drill bit thing happening inside of the vehicle, then why did the low pressure alarm only start last week? Why didn't it happen as soon as the vehicle docked?
The theory is that whatever that technician used, and the technician didn't tell me about this because of course it was an accident. He plugged it with some sort of glue, and that glue came loose.
And they know who it is now,
That's
right?
probably.
Have they identified?
Probably. They're probably in the gulags by now. I'm not sure. But,
Jeez.
they didn't identify whoever it was, which is good. They shouldn't. But
clearly, with the quality of the drill, it was me.
is that where your job that cannot be named? You work at the Baikonur
That's why he missed a
Cosmodrome.
couple of shows a couple weeks ago.
Yeah.
And then he couldn't talk because some reason
Anyways,
I think that's true. Anyway, moving on. Our next comment comes off of YouTube from John Eriksson. Would be great if you checked out the Swedish part of the Scandinavian space race. Sweden has a launch pad called S-Range, and I know too little about it. I was there looking at the outside 15 years ago. Unfortunately, there were no visitors center or launch schedule at the time. We almost hit Rudolph the reindeer on the way driving from there.
Oh, what a lovely story.
Yeah.
If you're still there in the area, John Erickson, it'd be nice to get some updated photos. Yeah, we definitely need to do some more research on that and see what exactly is going on, because that little update last week was very exciting.
There was lots of
no
stuff
idea.
going on in that area of the world, right? It's not just Sweden, but all the Scandinavian countries are kind of doing stuff.
Norway has things going on, and of course Denmark. Well, sort of. I mean, Copenhagen Suborbitals, which is based in Denmark, but that's not an official country of Denmark.
It still counts, though, right?
Yeah, I'd still count it. Yeah,
Yeah.
If they ever have an orbital launch or even a suborbital launch, I'm going to check that off for Denmark.
Yeah, and it's going to go into our launch count graphic, isn't it?
Yeah, that's right. Hopefully.
I'm just not going to say anything after I pissed off Europe last week.
Yeah.
I'm just going to sit here.
That's wise.
Called them small countries.
Yeah, sorry.
But he didn't just say
He's
they were
sorry.
small, but he used about 20 synonymous words to try to make it seem not so bad that he was calling them small.
Thanks.
Only making it worse.
Thanks for bringing it up again.
Yeah.
So
And here we are
Watch it.
digging an even deeper hole.
What have I started? Oh, my goodness.
Week 2.
We love you, Jared.
Okay, our next comment comes off of YouTube as well. A lot of the comments this week are coming off of YouTube. So if you want your comment featured, YouTube is a good place. But we also have other places you can drop your comments as well. The community forums, Twitch, Twitter. Yeah. So anyway, this next comment comes off of YouTube from D-Mart. And D-Mart says, 2 weeks in a row with no launches. What is happening, people? Except.
I know.
I mean, hang on. We had a launch minute this week, right? Because
Yeah.
Thankfully, surprise Chinese launch coming through for us.
Thank you, China. Thanks, China.
Coming in hot.
Yeah. Next week's going to be really exciting, though.
Yeah, it's 4 or 5 launches?
Yeah, we have a Falcon 9 launch.
The last Delta 2 ever.
The last Delta 2
I'm going
launch
to
ever.
it.
Oh,
I'm gonna be
man.
there.
I want to go as well. When
and
is
it's going to be 5:46 a.m. next Saturday. So 5:46 a.m. local.
Will we make
So-
it back in time for the show?
I don't care.
We better. That's going to be
It's
our
the last
alternate
Delta
footage.
2.
I think I want to go. If you don't see us on the show next week, potentially we're all out in traffic trying to get back from Vandenberg.
Yeah.
Could be a thing.
GoPro.
You know.
Yeah.
We'll see.
We could just stream on the road. Tomorrow begins right when we change
How
lanes
many
in this
times have
three-lane
I tried
highway.
that before?
Coming to you live, news from Jared's Jeep.
We did
Right,
actually have that
exactly.
graphic of the Jeep of Tomorrow.
Yeah, Rocket
the
Road Trip.
Rocket Road Trip. So,
Great.
which never worked. It just never worked because there's no bandwidth out near Vandenberg. And then especially for SpaceX launches, you have 1,000 people trying to pull bits of data off of no bandwidth. It just doesn't work.
Yeah.
I mean, I feel like if,
Yeah.
rocket road trip launchy things is something you want to see, if you want to see a stream on the road, leave a comment, and if there's enough support for it, maybe we can make Ben
Yeah.
find a way to make it happen.
I'm just going to say, it's super early in the morning, so my Jeep is going to be, dark. You're not going to see anything.
we just take
we
some
can
light
just string out-
video.
We can just string out a really long fiber optic cable with us, right?
Yeah, you could put a buoy
More
near my
buoys.
Jeep. Okay. So.
Anyway, enough of those death stares. Moving on. Our next comment is really, really cool because it was actually built in real time while the show was going. Ooh. So thanks to Ben for working on that. This next one comes off of Twitter from Chasing Atlantis, our friends there. Hello, Chasing Atlantis. We were also rocking the Occupy Mars SpaceX threads while watching tomorrow's live stream.
Nice.
Yeah.
Well done.
You got the memo at
Okay.
least. Apparently only me and Lisa did.
I did
Yep.
not. I don't have an Occupy Mars shirt because the one I had before was when I was 40 pounds less. So, so I need to kind of fix that. So, yeah.
Yeah,
Sorry.
well,
We didn't even plan it, to be honest.
got-
No, we did
well,
not plan it. No, we
also-
literally
Yeah.
showed up and we're just like, oh, man, we're in... At least it's
Yeah.
different versions of the shirt.
Sorry, but also not sorry because food's delicious.
yeah, that's true.
So,
If you have your own Occupy Mars t-shirt, maybe we can make that the thing for the show. Go and post your picture of yourself in one of these shirts in the community forums, community.TMRO.tv.
or just a space shirt, period.
Yeah,
Yeah.
that's a
Yeah.
perfect
Like,
idea.
I just found out about this company, NASA.
Oh, yeah, they've been around for a
NASA.
while.
Oh, they own space.
Yeah. Notorious astronautical and science.
Shirt.
Awesome.
Shirts of awesome.
Awesome. There we go.
That's a really good
I really
point, though,
like
Jared.
Chasing Atlantis' photo, though. So if you guys do something like that, rewind the show, take a photo of yourself in Occupy Mars with us on screen. That'd be awesome.
Yeah, this is
Space Administration.
North American Space Administration.
So what about the I don't know the Norfolk Association of Spaghetti?
Anyway,
And aluminum.
moving on. Seriously, we want to see your cool space shirts. You notice that the cast of Tomorrow always like to wear really cool space stuff. So take a photo, put it on our community forums. We'll start a whole thread going, and maybe we even feature one every show if it's really, really cool. So community.tmro.tv. But before we go, we would also like to give a very, very big thank you to all of the citizens of tomorrow because we couldn't do this without all of you. So specifically, thank you to our Escape Velocity citizens, the people that contribute $10 or more per episode. But we also have our Orbital citizens who contribute $5 or more per episode. Thank you very much to our Orbital citizens. And we also have our Suborbital citizens at $2.50 per episode. There are just so many more names, time after time after time, and I just can't even
Keeps
read them
on
all.
growing,
I feel like
too.
if I had to go and read every single one, I would be there for 5 minutes. It's crazy.
Well, if you think there's a lot here,
I mean, yeah, but wait, there's more, because there's also our ground support citizens. From $1 to $2.59 per episode. Thank you so much. I have my glasses on and I still can't even read
Yeah,
those
I can't read
names
it
because
either.
there's so many. Yeah. Honestly, you guys just blow me away. We're all so thankful for what you do. You make the show possible, and we couldn't do it without you. So thank you so
Thank
much.
you so much.
To check out all the different benefits you get for contributing and to find out more about helping the shows of tomorrow, head on over to patreon.com/TMRO. All right, that's our show this week. Next week, we are going to have on Chris Blackerby, who is the Chief Operating Officer of Astroscale, who are working on mitigating space debris and clearing out all the junk in space so that we can travel there without having disastrous consequences.
Yeah, or 15% chance of being hit by something.
Right.
Yeah.
So it's going to be a really cool show. I'm looking forward to it. We're probably going to be tired from the Delta II launch, but make sure you come and check it out. Also, don't forget to subscribe, hit the bell, and click like if you want to support Tomorrow even more. Thanks so much for watching, and After Dark is up next. We'll see you next week.
Bye.
Where's my spoon?
We're so weird.
Give me my spoon.
We're so weird.
That guy from that video? When you have a spider on you?
What a show. Guys, that was really
That was
great.
a great
I really
show.
enjoyed that.
By
Thank
the way, we
you.
still have Mike from
Yes, we
NanoRacks
do. Can we,
on the
let's
line.
get the-
so
let's get the,
let's
TV.
wheel Mike back out here.
Mike, come on over.
Mike is getting Mike. So
You're in
Wait,
my
wait.
you're in
Let
my
me get
normal
the code.
spots.
and
All right. Sorry.
I feel like I'm going to have to designate Space Mike and NanoRacks Mike.
Yeah.
And I think NanoRacks Mike, you might be confused, but here you
Nano
are.
Mike.
We're wheeling you in.
Literally
Here
wheeling
he
in the
comes.
guest.
Isn't he lovely?
Like that for me. There we go.
Yeah.
I'm not going to make it look pretty because
It's okay. Was that too bumpy? Was that all right?
Are you okay?
Wait, how am I going to get back in my chair?
I'm good there, I think. It's weird.
Here, I'll come
seeing
over here.
myself.
All right. Do
I'll
we have
sit on
enough
the
room?
edge.
Okay.
Mike Inception.
Mike,
right.
Mike.
Mike.
Doctor?
Well done, guys. That was exciting.
Yeah.
Good.
It's
That was
fun.
really that was effortless. Thank you, Jared. Well done.
Yeah, well, thank you for coming on. This was super awesome, and I was already psyched about talking to you guys because we've seen a lot of the work that you do. So this was great to kind of bring that to people's attention. So
Mike, were you at the SmallSat conference?
Where at?
Did you go to SmallSat this year?
Is your mic on?
I didn't go. No, I sent Connor and Henry and Ajith, those guys.
Yeah,
You may-
I met a few of the
They had that
NanoRacks
room
people.
around the back corner kind of thing.
Yep.
Yeah.
Yeah, cool.
Yeah. Yeah, I big timed it. I just didn't go. I love it. That's concert viewer.
Delegated.
Not concert, conference, yeah.
Really excited that the airlock has made so much progress and that you guys are going to be able to launch that next year.
It is terrifying because it's like half the company working on it, and so it's just a huge resource thing. But it's going good, which is fantastic.
And it was really that easy to get access to that port.
So it's nuts. So the story that I don't want to tell, like on on TV, was that the reason we did this was actually because
We are still. We
I
are
was
still.
getting. I was actually pissed off about the fact that we
just-
couldn't use
Mike,
the Japanese.
hey,
Mike,
Mike, just
Just so you know, we are still live right now. This is the After Dark section. It does get posted
Great.
later, though.
Well,
so.
then perfect. So I'm okay saying pissed off, right?
Oh yeah. just in case you, I just wanted you to know,
Not
in
the
case
P
you didn't
word.
want to tell the.
Yeah. No. So it was such a resource that was in high demand. Like, and everybody just wanted airlock cycles, and we just weren't getting all the ones we wanted. And so, kind of, in a fit of anger, we threw our hands up and said, "Fine, we'll make our own airlock," and didn't think anybody was actually going to call our bluff. And so everybody kind of jumped in and said, "That's a good idea. Why don't you do that?" And I'm like, "Okay, we'll do it." And so we designed it, patented it, did all this other stuff. Still, I didn't really think we were going to have to do it. And then it became real. So luckily there's enough need for it, and for the Japanese one too. So we're not stealing the business or anything, but it was a decision based in anger, unfortunately.
Oh, jeez.
Those are always
Yeah,
the best
sorry about that.
decisions.
I mean,
And that's going to be the port opposite of the cupola module. Is that right?
Yeah, it's a no, I think it's a three port. So it's right next to the cupola.
Yeah, where cupola and the beam.
It'll actually be right
now.
next to Bigelow, and then that's where ARED is, the Advanced Resistive Exercise Device.
Oh, okay. Awesome. Now, the space stations, are you guys calling them wet workshops or?
So back in the day, von Braun called them wet laboratories or wet stations, and that's because they at one point had rocket fuel in them. Obviously you can't use the hypergalls or anything like that, but these tanks with oxygen and hydrogen in them, once you vent it out, you can use it. Humans can be in there safely. So he coined the term wet workshop, and we refer to that quite a bit.
And is the name that I saw for this is Ixion, right? Is that how you pronounce that? Are you still going with that name?
So we're one thing at NanoRacks that we're not good at all is names. So obviously NanoRacks in itself is kind of an odd name, right? I don't know, but it sticks. So Ixion, I encourage everybody to not look up what Ixion is.
Uh-oh, too late.
perfect.
To the internet.
Suddenly the Wikipedia page gets a huge hit. So in mythology, it's the father of the centaur, right?
Ooh.
And so the base, that makes sense. It's a centaur rock and all this stuff. But if you think about what the centaur is, it's a half horse, and the Ixion was not any part horse. Whoa. So it's not a great thing to name something after. So we've abandoned the name, and we're calling them outposts because that's what they are. And the first one's gonna be called Independence 1, and that's that'll be our first free flyer, and a little more traditional space names rather than people that love horses.
Oh man, yeah, yeah. Wasn't there like thunder attributes attributed to Ixion or something like that too in mythology? Yeah,
if you read the story in mythology, he turned. There was some deception involved, where they turned the horse into a cloud and all that stuff, and really, again, I highly discourage everybody from looking up that story.
Yeah, it's weird. Yeah, I remember seeing that when you guys put that out, and it was just like, what are they going for with this? But then, seeing the centaur connection.
There's a company that's also looking at commercializing aerospace called Axiom.
Axiom, yeah.
And of course, Ixion was just confusing for that as well. And so we've abandoned that name. They're called outposts, and that's what they're going to be called.
Now, a lot of the designs I've seen just have a pressurized module at the top of the interstage. Are you guys going to be reconverting the entire upper stage, or just that pressurized volume that you've designed?
So actually in this next phase of the study, that's what we're looking at, is what can we actually use. The study, quite honestly, may conclude that it makes sense to just build a space station from scratch. That's one of the risks of the study. But we're looking at the options, and you're right. There's one where we use a small section above the tank to outfit it that would provide kind of propulsion and basic power and ADCS type applications. But then there's the rest of the study where we're looking at robotically outfitting it, putting hatches in there, we're working with Paragon, who has these semi-rigid inflatable textile structures to outfit the inside. There's a lot of trade space there to be explored.
I even saw one that had additional docking ports, almost like it was like a docking node.
Yeah, but we've pitched that idea to a number of people. Right now there's only one node left on the ISS, and there's a lot of people that want it. Us, Axiom, Bigelow, to name a few, and we think that there's enough commercial interest and other interest to have more than one node access there. So that's a concept that we're including in this trade space. Is every time we take a port, we add a port or more.
I really like that.
That's a good
I really
idea.
like that.
Yeah.
And since it sounds like you're a fan of the gateway, are you going to try to push any of the independence or the airlock or any other hardware for the lunar gateway?
Yeah, so we got a number of things going on, and you'll see some news in the coming months about our involvement with the gateway. We've identified a couple aspects of the gateway that are really interesting to us. We have this satellite deployment thing that we do, and we have this the exposure module that we do, kind of a hosted platform suite. Mm-hmm. And there's a lot of opportunities on all these components, the PPE, the HABs, everything like that, as they go out to the lunar orbit. There's a lot of opportunity to do some other science, and that's where we're looking. Right now there's the Esprit module, which is a European designated module for the gateway that has a science airlock on it. Mm-hmm. And that's eventually going to come online, and we think that that there might be an opportunity ahead of that or complementary to that to also include the science airlock that we make.
That's so cool. How much was your guys' contract worth through the Next Step program?
That's a good question. I think I want to say more than less than $20 million. I don't know. I hired a team to deal with it.
I thought it was around 10, but I couldn't remember, so I thought I'd ask. Sorry, yeah, I've been asking all of my questions. We should ask questions from the chat room. Sorry.
This is the Mike and Mike show.
This is what happens when he's not in his hologram state.
Yeah.
Are you actually Hanny Zwarwart? Is that in Tubals or Tabbles or who is it today?
Trebles. Yeah.
Nope.
Are you sure?
Nope. Not me.
Okay.
After the second really good question from Trebles, I was like, you know what? I should have been logged in asking myself questions.
Oh man, there we go.
Oh my goodness.
I actually know your guest next week, and I'm gonna send him a little tip. Like, hey, if you start getting tough questions.
No, so you rig the game. You log in and ask him tough questions.
Oh yeah, take that, Chris.
You're the one that will be asking the hard questions.
It's just some dual sabotage
Our
here.
show is rigged now. No.
Well, that's good, right? You've arrived. Like that's a good sign.
Your username should be Racked with Mike or something like that. I don't know.
Oh, I like that. Yeah.
Mike Racks.
Racking with rack face?
Originally the company was going to be named Bonsai, which I think is a wonderful name for a company, especially one that deals with smaller experiments. And, I thought it was really pleasant. But now we went with NanoRacks, which is just I mean, it makes sense once you look up what you guys do, and you're just like, oh, okay, they're deploying nano satellites from these racks, and they have these rack payloads for inside and outside the payload. So it makes sense, but you do have to look it up first. You do, and then it doesn't make sense when it's like, oh, who made that space station? Who made that private space station? You're like, NanoRacks. Like, oh, well, that's a dumb name. Hey, not to harp on dumb names or anything, but you showed a picture of one of our satellite deployments, and it's the 2x3U form factor. The 6U. Traditional CubeSat is a 1U by 1U kind of thing, and just when we were designing the deployer, I had the CAD model and everything like that. I'm like, what's the name going to be? And I jokingly called it the double wide. Yeah, there's the picture. The double wide. The double wide. And you know what? Sure as can be, that became the operational nomenclature, the OPNOM. And now everybody calls it the darn double wide. It's like, you got to be really careful with what you name stuff. Complementary to that, I designed another deployer that can host one that's twice as tall, and it's called the Tall Boy. And that's stuck.
There you go.
Cheers.
Right?
Yeah, cheers.
That's cool.
That's a lesson to the listeners and to the audience out there. Be real careful what you call your stuff.
Nah.
Yeah. Or just go for it.
Let's
What
see.
is this question? There's a question from Twicked in the chat room. I don't know if you can even answer this. Have you ever calculated the price to play a single game of Tetris with CubeSats on the ISS?
Oh my gosh!
Oh, that's awesome. So let's think. Each piece of Tetris, each Tetris piece has 1, 2, 3, 4, right?
Mm-hmm. Yeah, so you could
it
have
would
like a
be the
3
equivalent
by
4U
1.
satellite, and we do actually have standard pricing. So so our company is on what's called the GSA, the Government Services Agreement, and so we have a standard price for CubeSats, and we also have a NASA shopping list. So I could actually figure that out. So have whoever that is shoot me an email. I'll figure it out.
That's amazing.
There's a CubeSat out of Cornell University that's going to be launching on the first SLS launch. The name escapes me at the moment, but it's actually 2 CubeSats that are going to split apart, and each one is 3 units on one side, and then it has an additional 1 unit strapped in, so it looks like those L brackets from Tetris. So, yeah,
Wow.
we could
Yeah,
make
one of
this happen.
one of the first satellites that I was a part of was one called MAST, and it was similar. It was a 3U thing, and once on orbit, it separated. These 2 separated, and there was a guy that went back and forth in between. It was a tethered experiment, and that would be, you could easily just put hinges and stuff like that. And, there's a call out to the eccentric billionaires out there who want to play Tetris in space.
Yeah.
Oh my
We
goodness.
can make it happen.
Oh boy.
But you could frame it around actually doing science, right? You could be like, this is a docking experiment, and we have to dock all the Tetris CubeSats togetger.
And we could even do it simply, like with magnets or something like that, so it's
Yeah.
all passive docking.
Yeah, that sounds good.
There's actually a lot of work being done with that. Yeah, docking is much more complicated than it sounds. There's a number of agencies doing things like that, and the Spheres experiment on station, based out of MIT. That's a lot of their experimentation's doing that. We're flying a NASA satellite off the NG-11 flight that's doing something very similar. Also doing inspection and then the first stages of docking. So Tetris sat, it might have some legit science.
Yeah. And for those, NG-11 is in reference to Northrop Grumman's commercial cargo flights, the 11th flight of the Cygnus. So.
Yeah, thanks, Space Mike. I kept stumbling on that because
We like to call it Orbital
ATK,
ATK, a space division of Northrop Grumman.
Okay. Gotcha. We've just gotten used to adding the ATK to everything and maybe
Right.
change it up.
Right?
Yeah.
There's a couple other questions that we have here in the chat room. Let's see. From CFIT, they're asking, what completely new skills have you had to learn as a company to deal with airlocks? Any real surprises?
Oh, definitely. So up until the airlock, a lot of our experiments are just that. They're experiments. This is a piece of legitimate space structure. We've built deployers, we've built things that are safety critical, but this is a whole nother world. We've had to learn how to connect this docking mechanism to the space station, and there's power, there's fluids, there's all kinds of things that go back and forth. Interestingly, one of the things we had to learn a lot about was they built a model for the neutral buoyancy lab for the NBL of our airlock, and we've had to learn to work with the flight operations directorate, the FOD folks, to make sure that the astronauts, when they're training to interact with this, are actually interacting in it the way that we have envisioned. So that's been a really fun surprise.
That's cool.
Wow.
Yeah.
Are there pictures of that that are publicly available?
There are, yeah, and if they might be public. If they're not, we can. If they are, we can chase them down and give them to you guys. So
I would love to see that.
That's awesome.
Yeah,
So
it's super
exciting.
fun.
Cool.
Good question too.
Let's see. Just another question that I have. What's your guys' timeline for your outposts and the first Independence module? I mean, I'm assuming you guys are still in the design phase right now, right?
Yeah, design phase. Originally, we were wondering if we could actually do a flight demo in this next phase, but we're seeing that there's a lot of things that have to be overcome for that. So what we're going to do in this next, it's about 18 to 20 month time period. Is we're gonna do all the ground demonstration units. So actually, your guest last week, Dave Maston, we're working with them. They have the Centaur tank that they're actually bringing to us. I'm sorry, 2 weeks ago. The group that you interviewed, Justin Kugler from Made in Space. He's we're working with them to explore, fabrication type applications for it, and among many other companies that that I've kind of mentioned, SSL, MDA, Altia Space Machines, Paragon, all these guys. So that's the next about year and a half plus is going to be that, and then assuming there's a follow-on after that, we could go to flight pretty soon after that, within a couple of years.
Wow. So pursuing that kind of makes you a competitor with Bigelow Aerospace. Do you guys have any sort of relationship with Bigelow prior to announcing these outposts?
Yeah, we do. So Bigelow's done some incredible stuff, and I'm just a huge fan. The beam module is groundbreaking in a number of ways. It dipped a toe into this commercialization of space platforms. Also, it's a hugely successful technology. It's really good.
Mm-hmm.
We were able to use some of the stuff that they developed to help in our airlock. For one, there's a lot of thermal analysis and structural analysis that has to happen, and it's pretty close there, right? We're 90 degrees off of them, so we're able to use a lot of the same shadowing models and things like that were developed for them, by NASA. Second, we were able to use the same SpaceX flight support equipment. So our vehicle, our airlock is going up in what's called the trunk of the Dragon. It's the unpressurized back volume, and that's the way that Beam went up. So we're able to already, because of the work that Beam did with SpaceX under the guidance of NASA, we were able to take advantage of that and know what sort of input loads we need to design to, what sort of grappling and things that we need, what sort of tool path determination had to happen.
Mm-hmm.
Wow. Very valuable.
Wow. So cool. So cool. I can't wait.
All right, I don't know about you guys, but I'm getting hungry.
Starving.
Hungry and tired, eh?
Are we?
It's 2 hours later here. I'm starving.
Let's go eat.
Yeah,
Come
right,
on
right.
out with us.
Yeah, just come through the TV screen. We'll take you to lunch. Take you to
bring the
Disney.
screen.
It'll be great. But yeah, Mike, thank you so much for taking time out of your Saturday. Go and get some food. We'll get some food. It's been a great week. So thank you
Guys,
so
I really
much.
appreciate it. Thank you again for the opportunity. So yeah,
Thank
Jay,
you.
Lisa, Base Mike, Jared, wonderful interview. I really appreciate it. And
Yeah, thank you so much for
really,
coming on.
all the plants I put on YouTube and Twitch and everything asked some really great questions, I guess. All right, signing off from Houston. Thank you guys. Have a wonderful day. And
See ya.
Bye.
thank you very much.
And goodbye to everyone still watching. This is the end of After Dark. See you next week.
See ya.
Bye. Bye.